All right, I will begin with a word of prayer. I think everybody's here. So, Heavenly Father, we thank you for this afternoon. Thank you for these students. Just ask you to be with us today. Help us to just cover the math that we need to glorify you, what we do. And I just pray you be with the students. Just help them to just correct any mistakes that they had on the quiz, and just to be able to succeed better on the test next week. And again, Lord, we just thank you for all your many blessings. Lord, in your name I pray, Lord Jesus. Amen. So I'll talk more about the quiz at the end of today, but I need to talk to you guys about lines for now, right? So what are lines? So this is in XY plane. So I'll just start with a picture, right? So here's my XY plane. Maybe my line looks something like this, right? And so on that line, if you pick 2 points, right? If you pick 2 points on the line, let's say this point, x1, y1, right? And you pick this other point over here, x2, y2. Right? So if we have these 2 points are on the line, then we can look at a little triangle, right? We can calculate the rise over the run, right? So we can talk about the rise, the delta x, which would be x2 minus x1, right? And the delta y, which would be y2 minus y1, right? Oftentimes those are referred to as the run. This is the rise, right? And what happens when you take the ratio of the run to the rise? What do you got? M equals delta y over delta x, right? So this is y2 minus y1 over x2 minus x1. So what is this called? This is so-called slope, right? This is the slope of the line. Now, right, the slope. If I had this right here, what would we call this? This point right here, the value on the y-axis. This is usually denoted by b, right? The y-intercept. And so if you know that b, you can write the slope-intercept form. What's the slope-intercept? We have y equals mx plus b. That's the slope-intercept form of the line. What else is there? There's also point slope. Point slope would be y equals to y1 plus m times x minus x1. This is point slope. If you don't know about point slope already, or you don't use it, you should consider using it. A lot of you guys are just, without thinking, a fan of y equals mx plus b. You've been taught to use it without thinking, and it makes work for yourself if you insist on using that. There are problems which, if you use point slope rather than slope-intercept, the problem just becomes, there's nothing to it. You just write down the answer, you're done pretty much. All right, anyway, we'll see that in the examples here. And then there's also the 2-point formula for a line. And that looks like this: y equals to y1 plus y2 minus y1 over x2 minus x1 times x minus x1. So all the 2-point formula for the line is just plugging the formula for the slope into the point slope formula, right? Can anybody tell me, is there any other common form of the equation of a line? What's another? So your book talks about the standard form, right? What's that? Well, there's no squared, but how about ax plus bx equals to c? Now, I know what you're thinking about. You're thinking about what you just said. You're talking about this, ax squared plus bx plus c, right? That would be the standard form of a quadratic polynomial, right? And we've spent a lot of time factoring those things, right? But let me just, not for today. Okay, well, not yet anyway. We can talk more about it at the end of class, but this is not a line. That's a parabola. We haven't even talked about how to graph that properly yet, yeah? That's after test 1. But the standard form of a line is ax plus by, excuse me, did I say x both places? My bad. What should I do there? This is supposed to be a what? A y, right. So, you know, I would also point out that generically speaking, we basically have, I guess there are kind of 4 different kinds of a line to think about. So you could have one that looked like this, one that looked like that, one that looked like this, or one that looked like that. So let's talk about the slope of each one of these. The last 2 are really special cases, aren't they? So what do we call the last 2? This is a horizontal line, right? And this is a vertical line, right? How would I generically describe these? This has slope positive, right? And that has slope negative. So we can say this much. If the slope is positive, the line is always increasing, right? It's an always increasing function. It's always going up and up and up. If the slope is negative, it's always decreasing, right? And if the slope is 0, right, that's horizontal, m equal to 0, then it's just constant everywhere, right? If it's vertical, what's the equation of a vertical line? If this is a, what's the equation? The equation is just, you know, x equals to a, right? I'll find a place, I'll put it up here. X equals to a, right? Can you put the vertical line into slope-intercept form? Can you put a vertical line into y equals mx plus b form? There's no y, right? What would delta y over delta x be for the vertical line if you tried to do it? If you take any 2 points on the vertical line, what do they both have? They always have the x coordinates a, right? So if you try to calculate the slope for a vertical line, you get number over 0, right? So there's 2 different sort of dominant schools of thought here. The one is just to say that the slope is undefined, and then other people like to say that the slope is infinity. All right? Either way, the slope's not a real number, okay? So just for the sake of being able to say something, let me say that the slope is infinite. That seems more fun. All right? Any questions? How about, what else can we say? Given, so this is a definition, right? Given y equals mx plus b is line, you know, with slope non-zero, number 1, y equals m2x, oh, my bad. I'm sorry, guys. I've written this in the way I don't want to. Let me fix it. I like the way I wrote it last class. I wanted to write it that way again. Here we go. So definition. Let y equal to m1 x plus b1 and y2 equal to m2x plus b2. All right. So we have two lines, all right? Then the lines are, number one, parallel if M1 equals to M2, right? And two, they're perpendicular if M1 is equal to what? Yep. Negative 1 over M2. Now, you're like, wait a minute, I thought it was M2 equals minus 1 over M1, right? Good news, those are the same equation, right? It's funny how that works. But now, what am I assuming about the two lines here for this definition to make sense? What do we know about M1 and M2? I'm assuming what? M1 comma M2 not equal to 0, right? Although, if you wanted to allow infinity in this story, it does still kind of make sense, right? So, what would you say about these two lines up here? These are like the quintessential perpendicular lines, right? A horizontal line and a vertical line, these are perpendicular. So in some sense that makes sense, because if you took 1 over infinity, what should it be? It should be 0, right, if you're going to make it something. So it does kind of still, if you allow to extend the slope to infinity, these formulas still make sense. Likewise, two vertical lines are parallel if what? They're both vertical lines, right? So two slope infinity lines are only going to be parallel if they have both infinite slope. I mean, the vertical line is going to be parallel to any other line with infinite slope. It's still the same slope. So if you want to extend the discussion from finite slope to infinite slope, you can do that. But anyway. Okay, so this is our toolbox. These are the things we have to work problems on lines. This is it, all right? So now let's work some examples using these ideas, all right? Sound good? So let me ask you to pan over here. Say. So example 1. I'll start out real easy. Suppose you got y is equal to, minus 11 plus 3 times x minus 2. If that's the formula for the line, what can you tell me about the line? What can you tell me just by looking at this formula? I can tell you two things. The slope is 3, and 2 comma minus 11 is a point on the line. I'm using point slope. I'm just comparing point slope to the formula I'm given, right? So this is the y coordinate of the point, and we subtract the x coordinate. So 2 comma minus 11 is a point on the line, right? How would you find the y equals mx plus b form of the line here? We do what? Algebra, right? So plus 3x minus 6, which gives us y equals 2. 3x minus 17. So there you go. There's the so-called slope-intercept form of the line, right? So to get from point slope to slope-intercept, you just multiply it out and collect terms. Yeah? What does the graph look like of this thing? Yeah, the y-intercept negative 17, which I guess I'll make this minus 10, maybe make this minus 20 down here. And all right, so what was that? Oh. Yeah. I'm going to have to report you to the maintenance people. There will be a fee. Last time that happened to a student, it was $200. Okay, I just made that up, but I don't know. It's almost believable, right? Let's see here. So minus 17. I'm just kidding. I think you guys would be happy if all of these chairs broke. I know I would be. I hate these chairs. I like the tables, you know, like I have classrooms with nice long tables you can work on. So much better. Anyway, so the y-intercept is down here, right? The actual point that's at is 0, comma, minus 17. And the way to graph this is the slope is 3, right? So that's delta y over delta x. So the way you can think about that is you go up 3 and over 1, you know? So if you want to think about that, if I'm starting at 0 minus 17, I should go, you know, you could pick a, whatever you have handy as a measurement. I have these. So I go over 1, like this, right? And then up 3. Roughly speaking there. So, I mean, very crudely. And, you know, I try. I don't have, if you have a ruler, you can do better, obviously, right? But so the line looks something like this, yeah? If you wanted to find the x-intercept for this line, how would you do it? Where's the x-intercept? Plug 0 in for y. Why would you do that? Because it's right here, right? So that's where y is equal to 0. So we just have to set 0 equal to 3x minus 17 if we're interested in the x-intercept. So we get 3x equals to 17. Apparently x is equal to 17 over 3. To be specific, this point right here, right, is 17 over 3, comma 0. That's the x-intercept. Yeah.
I didn't quite see where you got the second point there.
Which point? Oh, this point?
Yes.
I use my hand. So here's my unit of measure.
Right.
I go over 1, and then I go up 3. 1, 2, 3.
Gotcha.
It's very scientific. You know, if you had a ruler or maybe some graph paper or any number of things, you could do better. But this is a sketch, right? I'm not carefully graphing, let's say. What else could we ask about for this example? Let's try to get the most out of it. What if you wanted to find a parallel line? Right? We wanted to find a parallel line to the given line. How would we do that? What do they have? They have slope what? For this one? No, parallel. They have, yeah, 3. 3. So there are infinitely many parallel lines, right? Which one do you want to find? You guys give me a point, any point. 0, 0? Okay. So through, if we, you know, for m equals to 3 and the point 0, 0, we get y equals to 0 plus 3 times x minus 0. This is point slope, right? And so what we get is y equals to 3x. Now, some of you don't think that way, right? You're like, I don't know what this point slope thing you're doing. It's not how I was taught before. Whenever I did lines before, the only thing I ever had to think about was y equals mx plus b. I can always just use y equals mx plus b, right? I mean, you're not wrong. A lot of times you can use y equals mx plus b and it's not much work, and here it's probably the case, right? So like the y equals mx plus b land way of thinking about this, 0, 0 means what? that is the y-intercept, right? So b equals to 0. So y is equal to 3x plus 0. In other words, y is equal to 3x, right? So for this problem, using the, slope-intercept idea is also a quick way to get to y equals to 3x, right? If that's how you think about it, more power to you. That's fine. I don't insist that you use point slope. I'm just trying to suggest you could think about it. How about, so there's our parallel line, right? And let's finish this example here. Suppose we want a perpendicular line, and where did you guys want it through? You want to find it through the origin again? I'll try to do another example here later in class through another point, through origin. So perpendicular line has m equal to what? Not 3, but minus 1 over 3, right? Through a negative reciprocal of the given slope. So minus 1 over 3, which tells me that y equals to minus 1/3 x. There you go. That's the equation of the perpendicular line. And I can come back over here, right? And I can clutter my original picture with those lines if you want. So like the parallel line we found, it's through the origin, right? So it looks something like this, right? That's this one. Let me call this 1, 1. And then the perpendicular one we found, see, I guess I haven't done anything green that much, is like this guy. So that's 2. Notice that the here's something you could say. If two lines are, think about this, if two lines are perpendicular, suppose line 1 is increasing, what can you say about line 2? Is decreasing, yeah, and vice versa, right? So we good? Okay, let's do some more examples. Oh, so I would encourage you to have all of these formulas like on your formula sheet for the test, right? I mean, that would be wise, I think. I think you got room, right? All right, so example 2 here. Let's work a classic example. Find equation of line through, let's say, minus 3, 8 and 10, 2. So how do you guys want to go about this? I think a good, yeah? First find the slope. I think that's a very good idea. But even before that, I'm going to say that this is 0.1. And I'm going to say that this is 0.2, just for the sake of discussion, okay? So my slope, right, is y2 minus y1 over x2 minus x1. So I need to take y from the second point, which is 2, and subtract y from the first point, which is 8, right? And then take x from the second point, which is 10, and subtract x from the first point, which is minus 3. So what's that give us? That gives us minus 6 over 13. Now some of you, if you're just ignoring what I'm writing on the board, might have tried to do it yourself, right? And you might have taken the second point and the first point and interchanged their roles, right? What happens? Does it matter which one you call 1 and which one you call 2? Yeah, it doesn't matter at all, because all that's going to do is it's going to flip it to be like 6 over minus 13. Either you get plus over minus, you get minus over plus. The net is always going to be negative, right? If they're both plus and you flip the order, you get both minuses. It's like, it doesn't matter. Like, however you choose the points, you're going to get the same slope, as long as you're consistent. You got to make sure you stick with 1 minus 2 or 2 minus 1, both patterns, you know? Okay, we got slope. Now what do we do? What do we do? If you're me, you write down the answer. So y equals to 2 minus 6 over 13 times x minus 10. There you go. That's the equation of the line. We're done. Right? Now, what did I do? I used the point slope, right? I used point slope. My point, I used 10, 2. My slope, what we just found, right? And I just plugged those into the point slope, and that's my equation. Is that how you guys were taught to do it before? Kinda. A lot of people are taught to use y equals mx plus b, right? So if you're one of those people, the way you were taught to do it before is something like this. You're like, so I wanted to go through this point, right? So that means I need to set 10, right? Excuse me, I need to set 2, that's the y value, equal to, you know, the slope was what? Minus 6 over 13 times 10 plus b. And I'll figure out what b is from that, right? So this would make b equal to what? 2 plus 60 over 13, also known as 86 over 13, I think.
With the something negative still there? Because it was negative 6 over 13 times 10.
Oh yes, but I moved it to the other side of the equation.
Oh.
I got you. Yeah, I was isolating. I was solving for b. My bad. Sorry, I'm a slippery one sometimes. And then, so 2 is 26/13, right? So 26 plus 60 is 86, I think. And then, so lo and behold, y equals mx plus b. You got y equals to minus 6 over 13, x plus 86 over 13, right? That's how you folks who were taught that way would do this problem, right? Now, think about the quiz you guys just took, right? That last problem, I asked you to find the equation of the line. Did I say, find the equation of the line in point slope? Or did I say, find the equation of the line in slope intercept? I said no such thing, right? I just said, find the equation of the line, which means if, you know, this was the problem on the quiz, either this answer or that answer would be totally legit, right? Unless I specify, find a particular format, you're free to give any format which is reasonable. How do you get from here to here? If I didn't make a mistake. I don't think I did. What do we do here? Distribute? Yeah, so this is the same as y is equal to 2 minus 6 over 13x plus 60 over 13, right? So we're back to that same arithmetic, 2 plus 60 over 13, which gives us 86/13. So, right? So the reason I'm talking about this, guys, is that if you're more comfortable with the way I'm doing it down here, and if this is ingrained for you and you have to think about it this way, fine, that's fine with me. Do it that way. If you're confident about that way, do it that way. But if you want to learn an easier way to just find the equation, think about using point slope. See, because this took no work. We just wrote down the answer. And having an answer like this is useful too, because there's lots of information if your formula looks like this. I can tell you both the slope and a point just from that format. Here's another example. You know, if I have y equals to 17 minus 3 times x plus 2, what can you, I'm just trying to, not beat a dead horse here, but what can you tell me from that equation? I can immediately tell you the slope is minus 3 and has point what? What point is on that? Think through it actually, right? If you plug in minus 2, what happens to the formula? What happens to this formula when you plug in minus 2? See what happens when you plug in minus 2? This becomes 0, and you're just left with that guy. So it is manifest, it is clear that if this is the formula, minus 217 is a point on the graph. Now, on the other hand, right, if I have y equals to 10 minus 17x, like this, right, that is also a useful formula. It has information which you can read directly from it. What can I read directly from this formula? I can read that the slope is 17, right? And what else can I tell you? I can tell you that when x equals to 0, right? When x is equal to 0, y is equal to 10, right? And of course, this is a special point. This is the y-intercept. I'm not saying anything terribly deep here. I'm just saying stop and smell the roses with the formulas. Think about using ones you haven't used before. All right? So here, let's work another one. Suppose you're given 3x minus 10y equals to, oh, I don't know, 6. What would be an interesting question we could ask about this one? How about what is the slope of the line? Slope of line and x and y intercepts. So what would you do if I come up against a problem like this? What I do is I just solve for y. If you solve for y, it should answer most of the questions that we're being asked here. So if we solve this for y, we're going to get minus 10y is equal to 6 minus 3x, all right? Then to isolate the y, what do I do? Divide by 10, well, minus 10, right? So y equals to 6 over minus 10, minus 3 over minus 10, x, let me clean it up a bit. So y is minus 3/5 plus 3/10 x. So that wasn't the answer to one of the questions raised. That is the, what is this? This is the point, excuse me, this is the slope-intercept form of the line, right? So from this, I can read some things, right? Like m is 3/10, the slope is 3/10, right? The y-intercept is minus 3/5, or perhaps more precisely, it's at 0, comma minus 3/5, right? That's the y-intercept. What about the x-intercept? How would you find the x-intercept? Now, somebody in the last class said, wouldn't you just solve for x? Just like we just solved for y. I really like that answer. It's rather creative, but that's not actually what I tend to do. I'm lazier than that. If you want to find the x-intercept, we're looking for where y is equal to 0, right? So to find the x-intercept, I just look for y equals to 0, and you just plug that in here. I mean, you could put it down here if you wanted, but just go to the original equation. It's easier. Put y equal to 0 here. We get 3x equals to 6. What's x equal to then? Apparently 2. Yeah. So x-intercept is at 2, comma 0. There's also an intercept form for the line, where if you have the format for the line in a specific way, you can read off both the x and y intercepts all at once. But I don't much feel like deriving that today. If you don't mind, I won't. I mean, we certainly have enough to work problems with already, and I almost never use that form of the line. Anyway, what is interesting here, though, is if you know the x-intercept and y-intercept, what can you do? Easily. And this is the only thing I expect you to be able to graph, right, on this test is a line. So I'm not saying that that's actually a problem on the test. I'm just saying it could be. Let's see here. So the y-intercept was where? 0 minus 3/5, which is kind of sort of here-ish, right? Where's the x-intercept? 2, 0, which is kind of sort of over here, right? Once you have two dots, then you can play the connect the dots game. And there you go. That was an attempt. I just have to move the point. I should always draw the line first and then add the points if I was smarter. But there you go. There's the graph of y equals minus 3/5 plus 3/10 x, roughly speaking. So if I know the x-intercept, y-intercept, I know 2 points, and then I can connect the two. Anytime you have 2 points, you just connect the points, and you got the line graphically, right? And it goes on, right? Forever and ever and ever. Hey, that's pretty much all I got to tell you about lines. So I think that should be more than enough to do your homework. So with the remaining time, let's talk about the quiz, yeah? Now, so I'm not done grading, unfortunately. I had hope, but then turns out I had to make another quiz for another class, and I still sleep sometimes. I haven't gotten past that yet. But so I'm still grading. I've graded the first page on all the sections quizzes, so I've seen what happened there. And so I will probably make the test a little bit shorter. The quiz was a little bit long for you guys, which is unfortunate. Not for everybody, but for some people, it was too long. I did have some people completely finish, and I think I'll have some perfect quizzes in there. I don't think it's like impossible, but it's just a little bit too long. So I'll probably shorten the quiz. I mean the test from where the quiz was. So I don't know how you guys felt about it. The other section got robbed of a couple minutes because it turns out that if you try to ride the elevator right after convo lets out, it just doesn't come on the garage over there. Like it just services the lower levels. It never like comes up to level 9, which is where I parked. So after about 15 minutes, I was like, oh, this is dumb. I should have used the stairs. So anyway, they had a little bit less time for their quiz. Anyway, all right. So let's talk about the quiz. That said, I did challenge them. If you ran out of time, like think about this. Why did you run out of time? What was it that you got hung up on, right? What did you spend more time on than you needed to? You know? That's a question that you have to answer for yourself. Let me show you one thing that I'm pretty sure a lot of you spent time on that you really shouldn't have needed to spend. Here's one. So like x squared minus 7. A fair number of you said that couldn't be factored, right? But the thing is, it can. And we've done problems like this, right? So this is the square root of 7 squared. And so the way this factors is just this. So this doesn't have to be a hard problem. That's pretty much it, right? And then somebody else in the earlier section asked, wait, what if I put x equals to plus or minus the square root of 7 for that problem? By the way, some of you had quiz A, some of you had quiz B, all right? I've posted the solutions for both, and I've also posted blank copies of both. So if you took quiz A, you can practice on quiz B afresh, right? And vice versa. There is some overlap, but I would encourage, you do need to study both for the test. They're not exactly the same. There are problems on one that weren't on the other and vice versa. Like the test will be some sort of like, it'd probably be something like 80% based on quizzes A and B and 20% problems that I haven't put on the quiz. Yeah. The test is when? Wednesday. Yeah. So the one fellow was like, the instructions on this problem number 1, the instructions were, what were the instructions? Do you guys remember? I'm paraphrasing. I can read, I have it here. My instructions were factor the polynomials below completely over R. Factor the polynomials completely over R. All right? So why is this not an answer?
That's solving for X, not factoring.
That is exactly, that is solving. That is not factoring. Factoring and solving are not the same thing. So when you're asked to factor, right, or you're asked to simplify, right, these key words in the instructions, factor, simplify, those are instructions that are typically given in problems where the answer is an expression. An expression is not a number, it's a formula that's just sitting there on its lonesome. Like this is an expression. So factoring is when you take this expression and rewrite it as a product of these two expressions. That is the answer. This is not the answer. This is an answer to a completely different problem. I say completely different, maybe that's a little bit too strong a language. This is the solution to what? This is the solution to x squared minus 7 equals to 0, right? Is it related? Absolutely. Is it the same problem? No. Right? So if I ask you to factor and you give me solutions, I will take off a lot of points. All right? To me, this is a serious error which needs to be corrected. All right? I think I did give you like half credit on the quiz because I'm not too mean on the grading on the quiz. But, you know, that is a serious mistake. Okay, which is, by the way, easily fixed as well, right? Like it's not a hard mistake to fix. Just you need to separate. This is, and if you have this confusion, you're not alone. Like at least half of the class has interchanged in their mind the problem of factoring and the problem of solving, right? It's fuzzy thinking. It's very easy to do this to get these intertwangled because it seems like they're the same problem because they involve many of the same steps, right? But they are logically distinct. Here's another one. X squared, not x squared, but x to the 4th minus 81. Let's talk about that one. A lot of you had that one or something like it. So here, a lot of you did this much. So you're like x squared minus 9, x squared plus 9. And I was like, good. This is a good start. Now finish it. See, you're not done. Because you can still do more. Because this is not prime. That factors into x minus 3 times x plus 3. Now x squared plus 9, that is, as far as it goes, right there, that was the answer for that one. Now, I'm going to give you like half credit for that sort of thing, but I do want you to understand factor completely means factor completely. Yeah.
So I broke that down as the second one, the x squared plus 9 is x plus 3 squared. Is that wrong?
Yeah, x plus 3 squared.
I answered that as x minus 3x plus
So x plus 3 squared is x squared plus 6x plus 9, which is not in here. So that's a different animal altogether. Now here's another one. I think probably only 5% of the whole class got this one right. All right, maybe 10%. It's pretty rare, and it's okay. Like I was expecting most people to get this one wrong because I have not spent a lot of class time on it, and it's easy to forget about this as a pattern. I certainly don't promote it that much in my teaching, but it is something we should think about a little bit, and that's why I put it on the quiz. So x cubed plus 3x squared plus x plus 3. What's my goal on a test or a quiz in a math class is for the test or the quiz to pretty much cover everything we've covered in class or homework. This is my usual goal. So if I covered it, it's probably there somewhere. Right? Now, if that doesn't happen, it's because other concerns are weighing on me, like it was too long and I need to cut something, right? But it vexes me to not cover everything, like because I want the quiz or the test to be representative of what we did. Anyway, so this one here, a lot of you got wrong, and I completely get it. Like we didn't spend a lot of time on this. There was a couple problems in your homework like it, but not that many. So some of you factored an x out from this. This we cannot do. There's no x on the 3, so you can't just factor x out. Now you got the right idea though, that's kind of in the right direction, because we can factor x squared out of this one. These two, right? So x squared times x plus 3 there, right? That's just the first two terms. See that? Then use your imagination. X plus 3 over here is really 1 times x plus 3, right? If you see that, then we can use the distributive property. And this usually goes under the title factoring by grouping to do like this. Now, somebody else asked me in the last class, they're like, I wrote x plus 3 times x squared plus 1. Is that okay? The answer is, yeah. The order of the factors can always commute, you know? So that was how that went. And then you're done, because like you cannot break x squared plus 1 down further unless you got complex numbers. Now, I'm only one section into grading page 2 at the moment, but I can tell you what I've seen so far. I see lots and lots of people using the quadratic formula. Lots of people using the quadratic formula and not using it well. Like they're floundering. And so I would encourage you, as you're studying this weekend, take a look at the solution and see how I solved the problem. I think you should see that the way I solved it was easier than what you tried to do. But anyway, obviously you guys are studying. I have had certainly worse college algebra classes before. I think there's hope for everyone. You just need to, like, this is why we have the quiz, right? If everybody got 100 on the quiz, first of all, I would be like, how did that happen? I didn't give 100 points. But after that, it would be so boring for me, you know? If you guys all understood everything, there would hardly be a point of being here, right? So I hope we can all learn together. Anyway, thanks, guys. Can somebody hit the button? It's the red button. Yeah, you can't see. This is the trouble. See, it's like over where you can't see it.
Oh.
Yeah.